Here are a couple examples of some arithmetic sequence in series. So here we have been given the sum of 10 terms of arithmetic sequence is 120. So S10 equals 120. The common difference is 2. What's the general formula? In sequence and series problems, we often want to know what the terms that we need to figure out to solve these problems are. We need to know the difference. So the common difference is 2. We need to know the number of terms. In this case, the number of terms is 10. And we need some starting point or some fixed point on the sequence. Not the series, but the sequence. So we often want to know what A is. And we can, once we know these three parts, we can write it into the general formula. So we can solve this for A, because this is the only unknown we have, if we can substitute into this series formula here. And we're going to use this one there. And so Sn, or S10, is equal to 120. That's going to be calculated by, it's going to be n over 2, so 10 over 2, 2 times A, which I'm looking for. The number of terms is 10, so it's going to be the n. 10 minus 1 represents the number of steps between the first and last term, times the common difference. And so that represents my just filling into the formula and giving us one unknown to solve for. So solve this. I'm going to divide both. This is going to be, this 10 divided by 2 is 5, so I'm going to divide both sides by 5. And I'm going to end up with 24. Is equal to 2a plus 10 minus 1 times 2 is 18. 2a equals 6, so a is equal to 3. So now since we figured out all three terms, we can write the general formula. Sn is equal to n over 2, 2 times 3, so I'm just going to make that into 6, plus n minus 1 times the common difference is 2. Now this asks for the general formula for a sequence, so we need the Tn. So the Tn is going to be 3 plus n minus 1 times 2. And you can simplify that or leave it in that form. So given the arithmetic sequence, determine the sum of the series. So this is arithmetic, so it's going to progress. So this happens to be T3, so maybe I'll label that T3, 4, 5, 6, 7, 8, and this is T8. So we need to be able to come up with D, N, and A. Well, A is here, so if I can somehow get back to there, that would be great. I need to know the common difference and the number of terms. I can see that there's 9 terms. To figure out what the common difference is, we can just skip count here. We know they have 1, 2, 3, 4, 5 steps. And in those 5 steps, we went up plus 15. And I want you to recognize this is similar to finding slope, because D is analogous to the slope. My change in my Tn over the change in n is going to be d. And really that's the same as change in y over the change in x. So change in Tn, so I went plus 15 over 5 steps, means that my common difference is 3. So d equals 3. And I can do lots of different things to figure out A and the total series now, but in a situation like this, counting is always the most reliable way to do math. So I can just count back. So I'm going to go 0 and then backwards 3 more. So that's going to be negative 3. And I can actually just fill in this sequence: 6, 9, 12, 15, 18, 21. So that's what my entire sequence looks like, and I can just add this all together and find out the sum of the series. I'm going to use my formula for this one, so I'm going to find S9, and that's going to be sum of 4.5 terms. When I pair up the first and last terms, I'm always going to end up with 18, so negative 3 plus 21 That's the sum of the first and last terms. So if I pair up 21 and -3, 0 and 18, 3 and 15, 6 and 12, and 9 is half. So that's why we have 4½ terms. So when I calculate S9, S9 works out to be 18 times 4½. So 18 times 4 is going to give me 72. Times half is going to be 9, so it's going to be, looks like that's going to be 81. Okay, so S9, the sum of those terms, is equal to 81. So there's the sum of that series.